Okay guys, we are going to continue with the self quiz. So in the next question, we have the following data set and we're going to be using that to answer the question below. So it's 21 randomly selected students were asked the number of pair of sneakers they own. And basically we have those number of sneakers. So 4 students have 1 pair of sneakers, 7 has 2, 3 has 3, 3 has 4, 2 has 5, and 2 have 6 sneakers. So that's pretty much the data set that was given to us. We need to find the sample mean. So again, data set, as per the solution, I already copied that here for you guys. Okay, let's see here. X values, and then we have the frequency. So again, that's the number of pair of sneakers, and the frequency is how many students have those sneakers. So we need to find the relative frequencies, which is basically going to be the frequency divided by the sum of frequencies. So it gives us the percentage. So we can look at it rel dot frec. So about 90% of the student has 1 pair sneaker, 33 2 pair, 14 3 pair, 14 also 4 pair, 9% 5 pairs, and 9%, roughly 9% 6 pairs. So that's basically relative frequencies. And here we were asked to find the sample mean. So what is the sample mean in this case? So the sample mean is going to be the relative frequencies multiplied by the x values. So x values. So the relative frequency is basically the sum. So if you do x bar, x dot bar, that will give us 2.9. So where did that come from? If you look in your book here, you have the formula for the mean is the sum of, so this is the x in this case, which is the x values here, and we are multiplying that by the frequency. Remember, the frequency is f divided by n. So f here is the frequencies, so basically divided by the sum of the frequency, which is your n. So and then you are summing the product of each of those, so which is this. So you are summing so in this case, what the sum x val that time the relative touch frequency does is 1 times 4 plus no, so it's going to do 1 times 0.919 plus 2 times 0.33 plus 3 times 0.14 plus 4 times 0.1428 plus 5 times this and 6 times this, and you sum them together and you have this value. So again, this is how this is done, but you could have done this in a separate way, like by expanding this value. For example, you have 1 4 times, so it means that you're going to have 1 1 1 1 4 times. You have 7, so 7 student has 2 sneakers, so that means there's 2 sneakers 7 times. 3 student have 3 sneakers, there's 3 sneakers 3 times. 4 student have 3 sneakers. No, 3 student have 4 sneakers, so that's 4 sneakers 3 times. 2 student have 5 sneakers, so there's 5 sneakers 2 times, and 2 students have 6 sneakers, and there's 6 sneakers 2 times. If you write all these numbers for those values, you expand them, you can now use the formula for the mean by just summing and dividing by the numbers, which would give us the total number of which will give us the same value as 2.9. You can try that also, that will give you the same answer. So the total number of sneakers is 21. So if you expand these based on the frequencies, you're going to have 21 values of this. So they're going to be repetition, and then you can add them. So again, it's a way of thinking about these type of question to show that you really master these concepts, because it's very important. So we have the mean with the following code. So the standard deviation, again, formula is given in the book. Is in the page, which page is that? So page 47. So you have the formula for the variance. The standard deviation is just the square root of the variance. So again, the variance is 1 over n minus 1. So you do the sum of, you do each value minus the x bar, which is the mean. You divide by n minus 1. So 21 minus 1, which is 20 in this case. So here the formula is here. So sum. So again, each time we take, let's say 1 minus 2.9, 2 we square it, and we multiply it by the frequency, which is 4. Then we add to that 2 minus 2.2 here, minus 2.9, we square it and we multiply by the frequency of 7, and so on. And the sum of all of that, we divide by, we know the sum of frequency is 21 minus 1, which is 20. So that will give us the variance. So now we need to the square root of the variance, which is going to give us the standard deviation. So let's run this and see what we get. So 1.6. So again, same formula you see in your book, page 46. So this is going to be the two formulas. So the variance is given by this. So what is the first quartile? So again here, let's look at the code here. In the solution, you run your data, or you create a data frame of x value and the com sum. So remember, this is the cumulative sum. You add the frequencies cumulatively until we get to the frequency to the max of 1. So if I run this, so basically we are saying that there's one value, the cumulative frequency is 19%. For two value, we have 52% and so on. So this is the cumulative frequency. You see that because when we get to six sneakers, we have 1. So that's the cumulative frequency. So now what is the first quartile? The first quartile basically is about 25% of the data set. So we see that for 25% of the data set, we have roughly 2 sneakers. Again, this is an approximation because in this case, for 2 sneakers, there's about 52% of the observation that is already covered. So that's why in the solution, they use an approximation to give you the first quartile. So basically, we observe that more than 25% of the distribution has accumulated 2, but less than 1. So because remember, if you accumulate 1 sneakers, you represent 19% of the data set. But if you accumulate more than 1 sneakers, but less than 2 sneakers, most likely you're going to exceed the 25%. But now when you accumulate 2 sneakers also, 1 and 2, you represent approximately 52% of the observation. So that's why in this case, the first quartile again approximatively is the value is 2. So again, an approximation here, but we're going to see below with some other question where we can calculate those values. Similarly, for the median, it's also going to be 2 because at 2 sneakers, 1 and 2, we already accumulated 50% of the data set. And remember, the median is 50% of the observation. So that's the idea. For 75, it's going to be the third quartile, which in this case is going to be 4 or 3. So let's say because we accumulate almost 4 of the data sets so here we have about 80% of the data set, which is about 75 is the third quartile. So that's